Welcome to Tech Teach.
If we are going to send the data in the sense, suppose a digital signal is there. So you have seen like this is the digital signal. If you want to transmit it, time domain, this is the amplitude. If you want to send this data, its frequency domain representation was like a continuous in frequency domain. So in frequency domain, starting with 0, it is going to up to infinity. So this is the frequency domain representation. So it was saying like we can't send this signal. We had to convert it into the analog form. We need to convert it into analog form because of the channel that is band pass. If the channel is band pass, we can't send a signal that is baseband. So baseband signal is starting with 0 to some frequency. This is baseband, and band pass is starting with f1 to f2. Okay, so if this is the case, that is band pass, so we will not be able to transmit the baseband signal through the band pass channel. So there is a conversion to analog. So similarly, we will be taking note like why there is a need to convert signal, analog signal to analog signal only, or analog to digital, or digital to analog, or digital to digital, while sending the data in through the transmission medium. The analog to analog conversion is the representation of analog information by an analog signal itself. So analog signal is there, information is in analog, means data is analog, and we are going to convert it into analog signal itself. One may ask why we need to modulate an analog signal. It is already analog. That is, if we are going to modulate means we are going to convert, so that conversion is basically based on, will be done by the method that is called modulation. There is an analog signal itself. First of all, we are having an analog signal and we are converting it into analog again. So why there is a need to convert an analog signal again into an analog signal only, or why there is a need of modulation? The modulation is needed if the medium is band pass in nature, or if only a band pass channel is available to us. So like in the case of a digital one we were thinking of, so digital signal is having a range of frequency. In terms of frequency domain, it is having 0 to some frequency, but the channel that we have seen is channel is band pass. So if there is a band pass channel, then there is a requirement to convert this baseband signal with 0 frequency to some frequency having f1 and f2. So that will be, we need to convert. This conversion is called the modulation. So the modulation is basically required to make sure whatever the signal that we are going to send through the band pass channel should be into the band pass signal. Band pass we have seen here. So this is the channel. Okay, but our signal is having the frequency that is like this, 0 to f. So if we multiply this, because this is 0, so starting with here to here, suppose this is the f1 and f2 frequency, in between is complete f. So only this portion we will be able to receive at the output by multiplying these two. So this will not be working. So we need to make sure, like we need to switch this signal with 0 to f frequency and make sure such that it should be accommodating inside this band pass channel range. So we need to transfer this to make another signal, convert into another signal that should be not starting with 0. It should be starting with some frequency that is called fc, that is called the carrier frequency. And here the minimum should be f1 and the maximum should be f2. So now if we multiply these two, then we will be getting the output signal that will be the same as this one that we have already gone through in the previous slide. So this process of conversion is called the modulation. So this modulation is required to basically switch a baseband signal. This is a baseband signal, and now this is the band pass signal. This is called the band pass signal. So basically the modulation is required to convert a base band signal to a band pass signal. So if we are able to convert it into band pass signal, we will be able to transmit that signal through a baseband channel. Baseband channel. So this is the basic objective, even to convert an analog signal to an analog one. So in this case, here basically we were converting a digital signal to analog one to make sure this is becoming a band pass signal. So this is the basic objective to convert, and that conversion is called basically the modulation. So we are going to do the modulation. So in case of modulation between analog to analog, that is basically called the analog to analog conversion or analog to analog modulation. The modulation that we will be looking at, like in analog to analog modulation, there are three different modulation techniques are there. So one is amplitude modulation, then frequency modulation, and phase modulation. So one by one we will be looking at that. So here it is amplitude modulation. So as the name suggests, it is amplitude modulation, means we are going to modulate, or we are basically going to change the amplitude of the carrier. Basically in modulation we require carrier frequency. So this is like the input signal, or this is the message signal we basically called. This is the message signal, and this is called the carrier signal, or the carrier signal, or basically the carrier frequency. So a carrier signal will be there that will be having higher frequency, because here you can just see it is having low frequency, but here it is frequently changing. So in 1 second, how many times its cycle is being completed? So that is frequency. It is frequently changing, so it is high frequency. So always in modulation, we will be requiring a message signal. So requirements will be like a message signal. Second is a carrier signal. So these two signals, this is the message signal, and carrier signal is represented by like CT. So CT, these two will be there. We will be multiplying these two. So by multiplying these two, we will be getting the result. So that result will be called like ST. So this is called the modulated signal. This is the modulated signal basically. So modulated signal. So after modulation, we will going to take place. So once we do the modulation, so here modulation is like amplitude modulation. So amplitude modulation means we are going to change the carrier. This is the carrier. So we are going to change the amplitude of this carrier signal. So because here the amplitude is constant. Suppose it is 1 or it is A. So A is for all. All is having the amplitude of A only. Okay. So in amplitude modulation, we are going to change the amplitude of the carrier signal with respect to the modulating signal or the message signal. So message signal amplitude are likewise. So at 0 time it is having this value. Then again it is going to have the taking the shape likewise. So this is the shape of the message signal. Okay. So this is the shape. The similar shape should be obtained by the amplitude of the carrier frequency. So carrier frequency or the carrier signal is there. So this carrier signal is having high frequency. So this is the same frequency of the carrier signal, but you can just see its amplitude is changing. So initially it was amplitude was A. Now it has changed to this value. This value is higher than A. Then again going down, then it is lower than this one. Then again it is higher than, like similar to that. Then again it is again higher. Likewise, it will be keep on changing, and this change will be making a shape of the message signal. So you can just see, if you see observe this black dot. So this black dot is basically having the shape of the message signal. This is the carrier. Blue one is the carrier signal. Okay, the carrier signal is changing its amplitude with respect to the message signal. So that's why it is called amplitude modulation. Now we are going to send this signal. So this signal is having high frequency. Okay, it is having high frequency. So if it is having high frequency, that is called the FC. So FC is called the carrier. The carrier frequency is FC. So whatever is the FC, and this is the modulating signal. Suppose the modulating signal is having the frequency of FM. It is called the modulating frequency. So modulating frequency is FM. FC is the carrier frequency. Then add the output, that is ST is the modulated signal. After modulation, that is modulated signal. This is modulating signal, carrier signal. After modulation, modulated signal. So this is going to be modulated signal. So this is the frequency domain representation of modulated signal. So modulated signal is having the frequency pattern. So this is a frequency domain representation. So here FC will be the carrier frequency, and FC beyond this higher frequency will be FC plus FM. This lower frequency will be FC minus FM. So this is the advantage of modulating. So after modulation, frequency domain representation is having a range of frequency. This FC minus FM, and this is the FC plus FM. So this is nothing but the F2, and this is F1. Okay. So now if any band pass channel is there, then this signal will be able to easily pass through that band pass channel, because it is not having the frequency ranging from 0. Now it is having the frequency ranging from F1 to F2, or FC minus FM to FC plus FM. So this is the advantage of modulation. So this is the modulated signal. This modulated signal is converted into the frequency domain likewise. And now here the bandwidth of this signal will be given by the bandwidth of AM is 2B. So 2B is considered as, suppose FM, this is FM is there. Here it is like FM, it is given by the B only. So this is the bandwidth. Okay. So B is the bandwidth. Okay. So in that case, it is going to say like if it is AM, it will be 2B or 2B, or we can write it like 2FM. Okay. So this is the bandwidth of the AM, that is this one. Bandwidth of this signal is 2B or 2FM. This was the basic idea about the amplitude modulation and its circuit diagram. This is the circuit diagram. Circuit diagram for that is one, there is a requirement of message signal. Okay, so this is the message signal, and this is the carrier signal, and this is the received signal, that is the third one, that is ST. After modulation, that is modulated signal. So there is a circuit, like there is a FC is the carrier frequency, this carrier frequency generator. So this carrier signal will be generated by an oscillator. There is an oscillator. Oscillator is what? Oscillator is a device that basically generates frequencies. So oscillator is a circuit that will be generating a device that will be basically generating frequencies. So frequency means a signal that is having some frequency FC. Signal will be multiplied by the input signal. After multiplication, this is a multiplier. Whatever the signal that we will be receiving, that will be the modulated signal that we basically require. So this is the basic circuit diagram that will be able to implement the amplitude model. So total bandwidth required for AM can be determined from the bandwidth of the audio signal, that is AM is equals to 2BM. So audio signal, or basically it should be like input signal basically. So whatever the input signal is there, 2 times of that will be like 2B. Okay, so 2B will be the bandwidth of the AM signal. AM signal, this is also called like AM signal. ST is called either called modulated signal, or you can write it like AM signal. Next one is the frequency modulation. So one is frequency modulation called FM. So what is the FM? Is like frequency modulation. So here there will be a modulating signal, means message signal. There will be another carrier signal, that is CT. We will be multiplying these signals again. After multiplication, the frequency, this is frequency modulation. So frequency will be changing. So frequency of the carrier will be changing. So it's like this was the message signal. Message signal is high for this frequency range. So from here to here it is high, and here to here it is low, because it is 0. If it is above than 0, that means it is high. If it is less than 0, it is low, we can call it. Here the frequency of the carrier signal will be changing with respect to the message. So message is high from here to here, this frequency. So in frequency modulation, frequency of the carrier signal is going to change with respect to the message. So message is high, so frequency of the carrier signal will be high. If it is low, so here the frequency is low. High frequency means number of switching will be high. If it is low frequency means number of switching will be low. So this is basically called the ST. ST will be the after modulation, the frequency is there. So implementation or circuit diagram is like there will be a voltage controlled oscillator. So voltage controlled oscillator is a device that basically takes input a voltage. We will be providing a voltage as an input, and at the output it will be generating a signal. So signal means a signal with some frequency. So if the voltage is high, the frequency will be high. If the voltage is going to be low, the frequency will be low. So with respect to change in the voltage at the input side, at the output side, we will be obtaining a signal, but that signal will be varying in frequency with respect to the amplitude of the message. So this is how the FM is generated. The next one is like phase modulation. So as the name suggests, it is phase modulation. So we are going to change the phase of the carrier signal with respect to the amplitude of the message signal. So the message signal is this one, MT is the message signal. This is the carrier signal, CT, and obtained modulated signal is ST with phase modulation. So here you can just see it is having higher amplitude into the message signal. So the phase, we are going to have the phase. So PM signal is, we are going to change the phase basically. As we are going to increase the amplitude, the phase is going to change. Okay. So phase is here. Basically, we are unable to show like what is basically in terms of phase. So phase will be like we have seen. So if it is starting with here, it is having zero phase. If it is starting with here, it is having higher phase. Okay, so likewise the change in phase is there. So this change in phase will be resulting into the signal. So it is looking like this only. Okay, so this is how the with respect to message signal, the phase is going to change into the modulator signal. So how it is basically done. So here in case of like if we are having how it is basically implemented. So in phase modulation, so it has been observed like there is a relation between phase and frequency modulation. So it is like we need to differentiate. So whatever is the signal MT, if we differentiate it, okay. So because any sign MT is there, suppose MT is there, like it is represented AM sign. Okay, so this is the message. Similarly, the carrier signal will be like CT, AC sine 2 pi F C T. So this is the carrier. If we modulate is these two signals will be there, it should be multiplied, or with respect to the VCU, it will be obtained. So this is the message. If we differentiate it, MT, so D MT by DT is equals to AM sine will be like cos 2 pi F MT. Okay, and here we are going to have, along with this, we will be having, we need to differentiate with respect to T, so 2 pi Fm. Okay, so likewise, if there is some change in phase, so there is a phi. Okay, so there will be, along with that, we will be having obtained phase will be there. Separately, we will be having a phase component also. So this phase component, so whatever is the phase component, with this after differentiating, we are going to put it into the VCU. So this VCU that will be getting the voltage as an input, it will be generating change in frequency. So it has been obtained, observed like if we are going to have a message signal, and by differentiating it, after differentiating, we are going to give it to VCU. That is basically going to give us the phase modulation signal, FPM signal. Okay, so this is the basic idea about the phase modulation. So total bandwidth required for phase modulation can be determined from the bandwidth and the maximum amplitude of the modulating signal. So whatever is the maximum amplitude of the modulation signal is there, and the bandwidth of the modulating signal. So bandwidth in the sense it will be changing with respect to FM and the AM. So FM and AM is going to result into the bandwidth of the phase modulation.